Okay, so today we're doing two things. We're going to start by solving rational equations. This is pretty simple, okay? There's a couple steps to it. So to solve rational equations, we're going to multiply through by the common denominator to clear our fractions, so we don't have any. Now, common denominator we already know how to find. And in this case, we have two different denominators. So the common denominator is just both of them, x plus 3 and x minus 3. X plus 3 and x minus 3. So that is step one, to multiply through by the common denominator to clear our fractions. Now, before we go any further, I make a little box, and I call this my no-no box, which is dumb. That's a dumb name, and it's not mathematically factual in any way, shape, or form. But it does help me to remember. So, if you're seeing a test or a quiz or an exam for me, and there's a box, that should indicate, ooh, there is a value that x cannot have. It's a no-no. All right? So, we know with a fraction, the denominator can never equal 0. Because if the denominator is 0, the fraction is undefined. Now, we didn't have to worry about this when we were just adding, subtracting, multiplying, and dividing expressions. Because we weren't solving for x. X didn't have a value. Well, when we're solving, x now has a value. And because x has a value, we have to make sure that that value won't make the equation undefined. And the way we do that is we write our restricted values. What can x not be? Well, in this case, if x were negative 3, wouldn't it make that first one 0? So x cannot be negative 3. And if we look at this one, if x were positive 3, does it make that second fraction 0? So if we solve this and get positive or negative 3 as our answer, even though it's the answer we got when we solved, it doesn't work because those are undefined values. So we'd either have no solution or it might be an extraneous solution, which is, the word extraneous is like extra. It's an extra answer that doesn't really work. It's an extraneous solution. All right, so now we have it set up. Now's the easy part, solving. So when we solve, we're clearing out the denominator. So we're going to cancel x plus 3 with x plus 3. X minus 3 with x minus 3. So on the left side, we're left with x minus 3 times x minus 7. On the right side, we're left with x minus 9 times x plus 3. So we have some distributing to do. We're going to distribute over here, and we get x squared minus 7x minus 3x plus 21. And then we distribute on the right side, and we get x squared plus 3x minus 9x minus 27. Now, if I go to solve an equation, I have to get the x's on one side, and it doesn't really matter which side. Do you guys see that if I subtract an x squared, if I subtract this x squared from here, what happens to it over here? It cancels. It cancels on both sides. So, when I move this, or when I move this, it just cancels out. So the x squared goes away. All right, so then we're left with negative 10x plus 21 equals negative 6x minus 27. And then you guys pick, which side do you want to put the variables on? Which side do you want to put the constants on, the numbers? I'd probably move my variable over here because that just makes it positive. There's no wrong way, no wrong way. And then I would move my numbers to the other side. And so I get 48 equals 4x. And what's my last step? Divide by 4. So we get 12 equals x. Now, is 12 in the no-no box?
Yes.
No, so it's a good answer. It works. Now, actually, I put a check right there. I can do a check step, guys. If I plug in 12, I get 12 minus 7 over 12 plus 3. Does that equal 12 minus 9 over 12 minus 3? Let's see. So that is 5 over 15. Does that equal 3 over 9? What does 5 over 15 reduce to?
1/3.
1/3. What does 3 over... Okay, does it check? Yes. Okay. So this is how we solve equations. We find a common denominator and we multiply every single term by that common denominator. We make sure we don't forget about our excluded values, and then we solve that equation that's left. Alright, so number 2. I'm going to switch colors so they don't run into each other. Alright, on this one, the only thing x cannot be is 0, because you see if x were 0, this would be undefined, and that would be undefined. So that's the only answer x can't be. So if we get to the end and the answer is x equals 0, then there's no solution. Alright, so common denominator for 4 and x and 4x is just 4x. So every single thing, every individual little expression has to be multiplied by 4x. Each part of the equation, this term, and that term, all have to be multiplied by 4x. So here, everything cancels. And we get 1. Here, I can't forget that this is a negative 3. So the 4 is going to cancel, and I get negative 3 times x is negative 3x. And here, just the x cancels, so I'm left with 28. So I subtract 1. Negative 3x equals 27. This one's much easier. Divide by negative 3 and I'm all done. X is negative 9. And that checks. I did it in my head, but you could do it. Okay, on this one, we can factor out an x, and we're left with an x minus 3. So in this one, when I think about the excluded values for x cannot be 0 because that would make this one right here undefined. X cannot be 3 because that would make that one undefined. And it's the same for that one, so I'm good. So my excluded values for x are 0 and 3 because those values make that equation undefined. Alright, so we're going to multiply through by the common denominator. X times x minus 3. X times x minus 3. X times x minus 3. Alright, and then we go canceling. So this cancels with that. This cancels with this. And both of those cancel with both of those.
I thought you said then we go Carolyn.
Oh, that'd be fun too.
I've done that before.
Slowly.
Yes.
Why are you multiplying all of them by x?
So I can make the denominators go away. Do you see how I just canceled out all my denominators? So anytime you multiply through by a common denominator when it's an equation, you make your denominators go away. It's pretty cool. So you don't have any fractions anymore. Fractions are all gone. So what we're left with is x right here times the x plus 1 equals 3 times an x plus x minus 3 and 12 times nothing because it all went away. So when I multiply through by the common denominator, that's all I'm left with. And then we distribute over here, and we distribute over here. Oh, this time I only have one x squared. It's not going to cancel. So that means I have a quadratic equation. So I'm going to try to factor it, because factoring is always the easiest. But it's got to be set equal to what to be able to factor? Equal 0. So I got to move everything to the other side. All right, so are you seeing the quadratic formula?
Yes.
All right, so this stuff has to move over there. And so when things move to the other side of equals, what happens to their signs? They flip. And we know that because we're subtracting 3.
What happened to the 9?
The negative 9 and the 12 made a 3.
No.
Alright, so this gives us x squared minus 2x minus 3 equals 0.
Are we using the quadratic formula first?
We don't have to, because you can multiply to get 3 and add to get negative 2. This factors to x minus 3 times x plus 1. Now, what value of x would make this first factor equal 0?
3.
3. What value of x makes the second factor equal 0? Negative 1. All right. We have a problem. 3 was in the no-no. 3 is an excluded value. No.
So it'll just be negative.
So the answer is x equals negative 1. What was that funny name we called an answer that we get that's not really an answer to a problem? 3 is an extraneous. Oh, I hate spelling. That's correct though. Solution.
This is a lot.
It feels like a lot.
It looks like a lot.
Are we good? Okay, those of you that have already been to math today, is this helping you understand
Yeah.
a little bit?
My thing is like the no-no square.
Okay, so it's not it's not a real thing. It's not.
Just don't know like.
You'll never go to college and your professor go, "Oh, you left off your no-no box." No, it's not a thing. It just helps us remember our excluded values.
I just like don't. I don't know.
You don't know how to come up with
Yeah, I
it?
don't know like
Okay.
what to look for.
All right. Let's take a look at the last two, and I'll be a little more explicit in my explanation about the excluded values. There we go. All right. So, guys, we are trying to stick with more simple rational expressions. Equations. They can get more complex, and they will. For those of you that are planning to take pre-calculus next year. Okay? And some of you are certainly very capable. You can take pre-calculus. It's going to take some work. Others of you that are a little allergic to work may not want to take pre-calculus. Alright, now this one factors to x plus 3 and x minus 2. See, when I say we're doing simple ones, do you see how pretty it works out every time? That what we get is going to cancel with what we've already gotten? Yeah. In real life, everything's not this pretty. Okay, so here's a minus. We could switch that too. You know how we change that to adding the opposite? Alright, so we're going to go through, and before we multiply, here we go. Alright, here's your trick. What's the opposite of this number?
-3.
Okay, so x can't be -3. What's the opposite of -2?
+2.
Alright, so x can't be 2.
So that's it.
That's it.
Gotcha.
Because those are the things that make the denominator 0.
Okay.
Okay.
We're good.
Alright, so we're going to multiply through by the x plus 3 and the x minus 2. The x plus 3 and the x minus 2. The x plus 3 and the x minus 2. And then we cancel. Cancel.
Miss Wilson,
Cancel.
Do we have to do it that way, or can?
You're going to notice what's going to cancel, and if you don't want to write it, you don't have to write it. But I'm going to do it the same way every time. So we're left with x times the x minus 2. We're left with a negative x times the x plus 3 and a 10. So we get x squared minus 2x minus x squared, woohoo, not a quadratic, minus 3x equals 10. So the x squares are going to cancel this time, so it's a little easier. We're left with negative 5x equals 10. So x equals -2. Was -2 in the no-no? It wasn't, so that's our answer.
Do we put the square or box, whatever thing for all of them?
Yes. And you don't have to even write the box.
Okay.
I just do the box to help my students remember.
Okay.
All right, you try number 5. And if you get stuck, you let me know. I'm going to hit pause on the recording. Okay, so if we go ahead and change this, and then we figure out what values x cannot have. X cannot be -2 or -4, because this factors to x plus 2 and x plus 4 also. So that's our common denominator, and those are the values that would make this, or this equal 0. So we're going to multiply through by x plus 2 times x plus 4. X plus 2 times x plus 4. X plus 2 times x plus 4. Okay? And we're going to cancel, cancel, cancel. And so that gives us 7 times x plus 4 plus a -3 times x plus 2 equals 2. Distribute, and we get 7x plus 28 minus 3x minus 6 equals 2. So these two together make 4x. These two together make plus 22. So we subtract 22, and we get 4x equals 20, -20. So we divide by 4, and x is -5. Was -5 a restricted value? No. So that is our solution. X equals -5. Okay. So any questions about solving? All right. So that's what you're going to do today in math if you haven't already been. Then tomorrow in your regular math class you have a review, and Wednesday in your regular math class you have a quest. Oh man, that means testing twice in one day. All right, so let's take a vote. That would mean 2 different math tests in one day.
I have mine back to back.
And yours are back to back. And his are back to back. Are yours back to back?
Mine are.
Yours are back to back. That's a lot of back to back. Okay, so I don't like that. I don't like that. Okay, another option we have, and I don't mind doing this at all. Now that we're discussing this, another option I have is this. That is not your class. This. I could move our exam to Friday, Monday, and do 4 days of review first. Is that better?
Yeah.
Okay. All right, that's what I'll do. We're gonna go ahead and start reviewing because we have 10 minutes of class left. Okay?
So what about the cookie cake?
We will do the cookie cake Thursday instead of Friday then.
Okay.
Kind of rush.
Yes, but we're gonna start working on our review now. So I passed out the review, and you can't lose this packet because I'm not printing it again. I mean, you can lose it, but it would be very unfortunate. All right. All right, so here we go. And we're going to do a little bit every day until we're all done. Okay. This takes us all the way back to polynomial equations. It asks us to sketch the graph and list the roots, find the x-intercepts. Your exam, you're allowed to use your calculator. So, let's use it. If you have your calculator with you today, I want you to type in that equation. If you don't, make sure your calculator comes to class the rest of this week, okay? I have one extra right here. All right. Okay, so let's type in that equation. I'm going to type with you. So we've got x to the 4th. And if you're not real sure how to use a calculator, now's a good time to start asking those questions. Plus 3x to the 3rd minus 21x squared minus 43x plus 60, and then hit zoom 6. Zoom 6. Okay, so remember that zoom 6 takes you back to a nice screen. Zoom 6 gives you a good screen. Okay, it looks like it's crossing the x-axis 1, 2, 3, 4 times. Okay, we have a couple ways of finding where it crosses the x-axis, but if they're integers, the easiest way is to look at the table. Do you remember how to look at the table? To look at the table, you press the second button and the graph. Second graph gives you the table. All right. I can see from the table that an x value of -5 is paired with a y value of 0. An x value of -3 is paired with a y value of 0. an x value of positive 1 is paired with a y value of 0. And an x value of positive 4 is paired with a y value of 0. So those are my x-intercepts. They're also called the roots. So the roots occur at -5, -3, 1, and 4. So my x-intercepts are just those ordered pairs. -5, 0, -3, 0, 1, 0, and 4, 0. Okay, so now let's sketch what it looks like. We know we've got one here at -5. We've got one at -3. We've got one at +1 and at +4. Now, it's hard to tell what this is doing because it just looks like a whole bunch of straight lines, doesn't it? But this is an even degree function with a positive leading coefficient.
So it goes up.
So it goes rise, rise. It is passing through each one of these. So it passes, it passes, it passes. So because it just passes through, it doesn't bounce back, it doesn't pass with an inflection, it just passes through. Each of these, if we list it as a factor, would be to the first power because it just passes through. No bouncing, no inflection. So if the intercept is at -5, the factor is a +5. Do you remember this? That it's the opposite. If the intercept is a -3, the factor is a +3. If the intercept is a +1, the factor is x -1. If the intercept is a +4, the factor is x -4. Alright, so we kind of did these out of order. We already talked about the degree. The degree of this function is actually 4. It's a 4th degree, which means it's even. And because it's even and it has a positive leading coefficient, both ends go up. Both ends. All right. So as we worked through it, did it help you remember it a little bit? Probably when we first saw it, we're like, I got no idea. I have no idea where to start. So, you have your calculator. Use it. Let it help you. Let it help you remember. All right, so that is number 1. Now, let's look at number 2. This end goes this way, this end goes this way. So is this an even degree function or an odd degree function? How do you know it's odd? Because you're right.
One goes down, one goes up.
Good. They're opposite directions. Now, is the leading coefficient, is it positive or negative?
Positive.
It's positive because it's going down on the, as it goes to negative infinity, it goes to negative infinity. As it goes to positive infinity, it goes to positive infinity. Yep. That's a positive leading coefficient. Okay, so the equation for this graph would be y equals, because an equation always starts with y equals, or f of x, or g of x, function notation. All right, now, we see it passes right here, and this is -2, 0. That's a little hard to see. -2, 0. Alright? So, if it passes at negative 2, what has to be here? X plus 2. Now it passes straight through. So what power is this? If it passes straight through, this is the first power. What if it passed through with a squiggle?
Third.
That would be the third power. What's the real math terminology for the squiggle though? What was that word inflection. Good. Alright. Now, this one right here is positive 1, 0. So what would the factor be? X minus 1. Now, at this one, it doesn't pass through. It hits and bounces back. What does that tell us about 2? Do y'all remember that weird terminology we used? Multiplicity of the root? Multiplicity of the root. If it has even multiplicity, if that number's even, bounces. Odd passes. If it's odd but greater than 1, it passes with an inflection point. Okay, so we didn't get very far, but tomorrow we're good. We're going to be on a roll tomorrow. Okay, so I'm changing the calendar to notate that we're going to do the exam Friday, Monday. We're going to review all week, exam Friday, Monday. This is going to be so good for your regular exam, too.